Hello class, we're going to be looking at Chapter 10 on strings. Okay, so some objectives. We're going to be looking at the idea of literal strings. We're going to be talking about the variety of constructors and methods that are associated to the string class. Key topic, we're going to be talking about this idea of immutability of strings. So remember this word and make sure you know what that means by the time we get through this. We're going to be looking at methods that turn numbers into strings and vice versa. And then we're going to also look at some useful methods within some other classes, the character class as well as the StringBuffer class, which we'll really briefly cover today. Okay, we're going to spend most of the time on the string class here. The string class is a class that creates an object that contains a sequence or a string of characters, primitive data characters. Now the string class belongs to the Java language package, and therefore we don't need to import any special library in order to use it. Now, just like all classes, there's a number of constructors, a number of ways to make string objects, and there's a number of methods that we're going to be introducing. Now, unlike other classes, the string class allows the plus operator and the plus equal operator to be used upon the objects. They're used for concatenation, as we'll see later on. Okay, literal strings. Literal strings are a way of specifying objects within Java, and we put a bunch of characters between double quotes, and when we type that up, it's actually creating, in a sense, a string object within Java. We don't actually have to construct it. We don't have to type the word new string like for many other objects in Java. You always start with new followed by the class name in order to make an object. But in the case of Java with literal strings, here's an example right here, fish.dat. This is a literal string within the double quotes, and it's an actual object. We can have a variable that references it. We could supply a literal string object as an input to a constructor. In fact, we can even call a string method using, this literal object as kind of the object definition here. Okay. Now, suppose we want to put some special characters within the double quotes. Because some, there's characters beyond just the normal A, B's, and C's. And so to do that, we use what we call this escape character. We start with a backslash and then some letter after it to indicate some special character. So backslash n is the sequence for the return button on your keyboard. Backslash t is the special sequence of characters for the tab button on your keyboard. Some other useful ones might be backslash double quote, because suppose we want to put double quotes within the string. So how would we do that? We use the backslash. And suppose we want to put a backslash inside of a string itself, we would then use backslash for that. Okay, key concept of strings is that once a string has been created, it cannot change. It is what is called immutable. And this is a word that you really need to understand and you need to remember with respect to strings. Not all objects are immutable, but strings are. So what's the benefit? Why do we have some objects that are immutable? There is a safety to immutable objects in the sense that if I have multiple variables that might be referencing that object, if I reference it with this variable over here, I won't change. If it's immutable, I cannot change it and have this other variable who's referencing that same object. It won't see that same change. So it's nice. It kind of protects you a little bit. So there is a nice thing about immutability. So here's a kind of a picture, a diagram of that, where I have two different variables referencing that same exact object. And because this object cannot ever change, I don't have to worry about, S1, I always know will always have this value capital S-U-N. Now, if I wanted to make a copy of it, I could do that. I could, create S1 to be referencing sun, and then I could say new string that has that as well, and it will create a copy of it, but it's really not necessary. So this would be very, very uncommon to do, because there's no need really to do that. Now, disadvantage is this. You cannot actually change a string very easily. Suppose I had lowercase sun as my object, and I just want to replace a single letter within that string to a capital letter. I can't do that. What I could do is I could have some Java code that creates a brand new string. So it finds the character at position 0, it turns it into uppercase, and then it concatenates that with the U and the N. So I can create another string, but I cannot change that original object itself. If I were to do that, if I were to create a brand new string and then assign it, reference it to capital S-U-N, the old object would just be thrown away. So on one case, immutability is nice. There's a little safety to it, a little bit of protection in that object can never change. But at the same time, it's less efficient, because in order to ever change a string, I have to make a brand new string. So sometimes using string objects can be a little slower in terms of program efficiency and speed of operation. Okay, there's this idea of an empty string. So an empty string is a string without any characters inside of it. And it has, it's just backslash, backslash, back to back. There's two ways of creating that. And the normal way of creating that is just with backslash, double quote, sorry, misspoke. You could also create an empty string with new string without anything inside of it. But, like I said, the common way would be this way right there. I would probably not even do the second one. Now, very important, other big idea or big warning is, do not confuse it with a variable that I have declared, but I have not initialized to anything yet. This is very different. In fact, when I do this variable is actually pointing to nothing, pointing to no object itself. Let me diagram that a little bit. I want to make sure this is very clear. In this first case here, I have S1 that is pointing to an object that has the empty string. In this next case, I have, say, error message, my variable, which points to nothing. It has not been initialized. It hasn't been given a value yet. And so it literally does not point to any object at all. So this is the idea of a null pointer or a null object, whereas this is an example of a valid string. It's pointing to a string object. It just so happens that the value of the string is the empty string without any characters inside of it. But make sure you understand the difference between these two, because they're drastically different. Okay, constructors. Now, there are a variety of constructors for strings, but typically you won't really be using them too much. Typically, when you make a string, you'll just say, you'll use the literal string. You'll say something like this, S1 is equal to hello. That would be the normal way of creating a string. You could use these string constructors over here to create an empty string or to copy a string, but again, not used much at all. Okay, now we're going to be looking at a bunch of different methods. So we're going to go through a lot of methods, and I'm going to go through them fairly quickly, and I want you more to understand just the variety of methods that exist, and if you don't need to memorize all the details of each one of them. Actually, in terms of details, we're always going to actually have a reference sheet for you, a Java reference sheet on a test that will actually show you the methods and even constructors of the string class that you need to use, and it won't have all whatever 20, 50 of the methods. So don't necessarily worry about trying to memorize the details of all of them, but understand that they exist and understand them at kind of a high level. Okay, so the length method returns an integer of the length of the string. So flower has 6 characters, so that's what you see, that's what it returns. The character at takes a single input and it returns a character, not a string, a character, and it returns the character at that particular position where we start by counting from 0. So right here, W is 0, 1, 2, so we return the character, notice the character here, not the string, N. Okay, we could also, there's a substring method, and what it does is it returns a string, and it starts from the ith position, and it ends at the k-1 position. So it doesn't go up to the k position. So here's a diagram, a picture of it. So this would be the substring that would be returned by these two I and k position indicators. Now you could shortcut this. The substring method takes a single input as well. In that case, it points to the beginning letter, and then it extracts everything from there to the end of the string. Now, the valid values for I and k are always between 0 up to the length of the string. Okay, so for example here, emptiness here, substring 9. So let's label it 0, 1, 2, 3, 4, 5, 6, 7, 8. And then 9. 9 is the length of the string. Notice in this case here, substring 9, it returns the empty string because it's 1 after the ending here. Now, if I said substring 10, I get an error because that doesn't exist. But substring 9 references this kind of invisible nothing thing at the end, okay? So we have substring 2 to 5, which we showed up here. Substring 2, which starts with the H and gives us everything to the end, returns happy. Okay. Concatenation. Now, remember, we've used this before, I think, too. The plus is used to concatenate two strings together. Now, it's a shortcut way of you calling the concatenate method. So, same thing, but I think this is just easier to use. I probably would not ever use the concatenate. We could also use the plus equal as a way of saying result equals result plus S3. And then we could also concatenate numbers with strings where the number will automatically be converted to a string. Okay, the find method. The find method returns an integer. It returns an integer that indicates the location of whatever character or string we're trying to find. So if we want to find the first J, it'll look for the first J. It'll look for the first 2, returns the 8 right here. We could also look for a string. In this case, 2012. It returns the starting character of the 2012. I could say look for the first 2 starting at position 9. So it'll say, okay, I'm going to start at position 9 and start looking for a 2. Oh, I found it right here at position 11. If I were to search for something that does not exist, either a string or a character that is not found within the string, it will return a -1. And there's a kind of closely associated method called last index of, which in a sense you could say it finds the last one, or you could say it searches from the right hand side. So starting from the right hand side, it looks for the first 2, and it returns that number here as 15. Okay, more methods. We're going to look at some comparison methods. Now, remember that with comparisons, if I were to say S1 equal S2, the equal here is saying are the 2 objects pointing to the same, or the 2 variables pointing to the same object? Are the variable references identical to each other? So in this case right here, say they both point to hello or hi, S1 is equal to S2. But there's this equals method which is a little different. Instead, it's saying are the contents of the 2 different objects the same? So in this case, S1.equals, it's different. It's different than the equal. Instead, it's saying, are the contents of the objects the same? And so in this case, it looks deeper. It looks inside the objects, and it compares them letter by letter. And if they're the same, it returns a true. Now, we could also use the ignore case, so it's case insensitive. There's a compare to, so I can compare 2 different strings to see if they are the same or not. And the easiest way to think about it is by maybe giving some examples. B is less than C. BC is less than C. BA is less than BAA. Okay. Other examples maybe would be capital A is actually less than lowercase a. So that might be a little non-intuitive, but that's using the compare to, which is subtracting the Unicode values of each one. And of course, there is also a case-insensitive version of that as well. Okay, replacements. So I could modify a string, but I want to be careful when I use that word modify. I'm changing the string and then I'm returning a brand new string. So I want to highlight this part, return a new string. So that's the key thing to notice here. That because again, strings are immutable, so none of these methods ever change the original string itself. It only can return another string. So the trim removes the spaces and at the front and the end of my string. The replace will change one character with another character throughout this entire string. To uppercase will turn it into uppercase, as the name suggests, and then to lowercase turns it all into lowercase. Or I should say it returns a string that is all lowercase. Now suppose I wanted to change the string itself. Remember, I can't do that. So what I can do though is take whatever value is returned and reassign that variable to point to that. So this is what I mean by that. So suppose I had something like S1, and it's pointing to this object that is hello. And if I want to call it to upper string, I can do that, and what happens is a brand new string is made with the capital letters. And then I could say take that return value and assign it to S1. So what would happen is that this pointer would now be pointing to the new object that was created. The original object is still there and will eventually be thrown away, garbage collected. Okay, so make sure you don't do this. This is a common mistake where you say, okay, I want S1 to turn into uppercase, and so you just type in your Java code S1.to uppercase. It returns a value, but S1 does not change itself. And this is the line above that you probably wanted to do, but you mistakenly did not do it, and you'll get some behavior in Java that you did not expect. So this is a very, very common mistake. Okay, conversions. I could convert numbers to strings in a variety of ways. One of the most straightforward ways is just by concatenating the number to a empty string. And I would say this is, to me, the easiest way of doing it. But other ways there are available. There are methods that do it for you. There's a toString method that is within the integer wrapper class, and as well as the double wrapper class. So this is one way, or an alternative way of turning an integer to a string or a double into a string. And we have a third way, which is there's a value of method within the string class that can take a variety of different numbers and convert it, create a string for you as well. So all sorts of different ways. I might just go with number one. Okay, more formatting. Now, there's a lot more detail to be kind of read and looked up on this, but just at a very high level, there is a class, a library, decimal format. So what we can do is we could use this to format a number in kind of a very flexible way. I could have it have a $sign in front. I could have it have some commas, you know, every 3 digits, you know, for thousands and millions. So I could have a very flexible format defined right here. So when I make this, this object here, the money object with this format, then I could feed it with some number to create a string that has that, or you know, the format that I had created. So this is something to look up. Just know about its existence, and you know, not right now you don't need to memorize this, but you can always look it up later on if you want to format dollar symbols very nicely, and like I said, commas within big numbers. Okay, yet another way to format numbers, or format actually strings. There's a very useful method called the printf method within system.out, and it allows you to define a string, what's called a format string, and within that format string you have these different kind of parameters, specifiers, so that this parameter gets plugged into here. The % is the key kind of signature of this. The M will get plugged into here, and %D stands for decimal. So this is saying plug this number and convert it into a decimal. Take this parameter, plug it into this second one here and convert it into a decimal. Take this parameter here, convert it into another decimal, and take this parameter here and plug it into here, converting it to a floating point. F stands for floating point. And there's other special things about it. This 0 here means I want to have a leading 0 in front of it. The 7 here means I want it to be 7 characters long, and there's a space here that you might not see. That's the 7th character. 0 or 1, 2, 3, 4, 5, 6, 7 characters long, 2 characters to the right of the decimal place. So a lot of fancy stuff here. Again, read it up if you want more details, just covering it at a very high level. Okay, now I could also go the other way. So if I have a string, how do I convert that into a number or into a double? So I have what's called a parseInt method or a parseDouble method within the integer or double wrapper classes that can allow me to turn strings into numbers. Now, what happens if I'm trying to convert the word hello into a number? There is no integer for hello, and so what happens is we get what's called a number format exception error if the string that we feed it is not a valid number. Now, in that case, a nice way to handle it is by using this try-catch kind of structure where I say, well, try to convert this string into an integer, but if you get an error, if you get a number format exception error, catch that error right here and print out a message that, oh, I need to re-enter it and loop around and try again, for example. Okay, character methods. Okay, so character is another class, not to be confused with the string class. It's another wrapper class, and a wrapper class is a class that contains primitive data. So I could have an integer wrapper class that contains integer primitive data. I could have a double wrapper class that contains double primitive data. And we also have a character wrapper class that contains primitive data as of characters. Okay? And it makes it into an object that is holding that primitive data. So there are a number of actual useful static methods that we can use within this character class. Some examples. All of these return a Boolean. So if I want to discover, is this character a digit, a letter, uppercase, lowercase? Is it white space, where white space is a tab or a space or a new line? I can use these static methods that are within the character class. And these will be useful in your next lab. I could also do some conversions, so I could take any character and convert it to uppercase, or I can convert it to lowercase. And again, in converting it, it returns another character. And there's also a digit method. I'm not going to go into detail of it. Probably not used a lot. Okay, finally, last thing. I'm going to talk briefly about a StringBuffer class. It's another kind of class. It's different from the string class in one important way. Remember, the string objects are immutable. Once I make a string, I cannot change a single character within it. StringBuffer class, on the other hand, is mutable. I can change it. So if I have, if I have an object and it's pointing to a string buffer and the word is hello, I can call a method and change anything I want within that string buffer. I could change a piece of it, a character within it, a bunch of stuff within it. There's quite a bit I can do. I can insert quite a few characters, append some characters to the end. I can delete some characters, and then all the other characters will move accordingly. So I'm not going to get into all the different methods of the StringBuffer class, but just know that there is this thing called the StringBuffer class that is quite similar in kind of the idea to the string class, but the major difference. The string class is immutable, cannot change. The StringBuffer class right here, it is mutable. I can change single pieces of that. Okay? And there is a method that allows me to actually convert string buffers to strings and vice versa. Okay, just to finish up here, I want you to try to think of the answer to each one of these, and I'll just slowly open them up and reveal it. But just you could maybe pause the video before I open them up. And I would make sure you understand this idea of immutability quite well and the advantages and disadvantages of that. Some more here. And lastly, again, big difference, idea of mutability versus, or immutable, strings being immutable, string buffers being mutable, changeable. Okay, class, have a good day, everybody.